If there are three observations, 15, 20 and 25, then the sum of deviation of their observations from their arithmetic mean is. We know that sigma x minus x bar is equal to 0 always. So the answer here in this case is 1, that is 0. See, it is not relevant here that we have been given observations as 15, 20 and 25. If the observations were given something else also, then the sum of deviation from the arithmetic mean will always be 0, because sigma x minus x bar is equal to 0. This can be very easily understood here. Let me take an example. Suppose this is a observation line and our mean is here at the center of the data range. This is my mean. So now the distance to the left of it and the distance to the right of it, both are going to be same. Here suppose the distance is negative because the number are smaller than the mean if the number have been arranged into the ascending order, and suppose the distance here it is positive, and both are going to be numerically same. So the total of both the distance would be 0. So we can very easily say that the answer here is 0. What is the median for the following observation? Now to find out the median, we first have to arrange all the observation into ascending order. Let me arrange all the observations here. We can start with 4, the next is 5, then 6, then 8, then 9 and then 11. Now median is the positional measure. Median is a measure which lies at the center position of the data range. So here we have total 6 observation, n is equal to 6. So now if you want to find out the center position, then we need to find out the center of 2 center observations. So here this is 6, this is 8, and actually we want to find out the center of this. Now how can we find out the center of this? It is very easy. 6 plus 8 divided by 2, so that is naturally going to be 7. So we can very easily say that our answer is 7 here. What is the model value for the numbers 5, 8, 6, 4, 10, 15, 18 and 10? Now the model value Z is equal to highest repeated observation. Highest repeated observation. So here in this case there is no any observation which is repeated, so we can say the answer is none of this. What is the geometric mean for the numbers 8, 24 and 40? The formula for the geometric mean is equal to nth root of the observation x1 into x2 up to xn. So here in our case there are 3 observations, so the formula can be applied like this. It will be third root of 8 into 24 into 40. Now it will not be possible for us to find out the third root or the cube root of the multiplication of this number on our simple calculator, so we will apply some kind of mathematics here to reduce it. It is easily understandable that I can write 8, this 8 as 2 raised to 3 into 24 is nothing but 8 into 3, so I can write it is 2 raised to 3 into 3, and the 40 is 8 into 5, so I can write 2 raised to 3 into 5. Now I can take this 2 raised to 3 out of the cube root bracket, so I can say it is 2 into 2 into 2, and still we have to find out the cube root of 5 into 3 is equal to 50. So we can easily say our answer is 8 into cube root of 50, which is number 3 in our case. The harmonic mean for the numbers 2, 3 and 5 is. Now the formula to find out harmonic mean is n divided by 1 divided by x1 plus 1 divided by x2, and it will run up to 1 divided by xn. So harmonic mean is nothing but reciprocal of the mean of the reciprocal of the observation. Let us apply this formula in our case. So we have 3 observations here. So here we can say that n is equal to 3. By applying the formula of harmonic mean, we can write down harmonic mean here is 3 divided by 1 by 2 plus 1 by 3 and plus 1 by 5. Now this can be very easily solved by using calculators. Let me show you. Okay, now I am writing here 2, and this is the button of finding out the reciprocal of 2. If you have a simple calculator, then you can just press divide n is equal to find out the reciprocal of the number. Remember, divide n is equal to. I am pressing here 1 by x button to find out the reciprocal, which is 0.5. So you can see it is a reciprocal of 2, which is 0.5. Now put it in the m plus. Again write down 3 and the reciprocal, that is also in m plus. Write down 5 and the reciprocal, again m plus. So recall the memory. MR is the memory recall button. Recall the memory. We have 1.033333, which is nothing but total of 1 by 2 plus 1 by 3 plus 1 by 5. Now just divide this number by 3 and we are getting 0.344, but this is not our answer. Actually we have divided here total of this 3 number by 3, but we want to do exactly the reverse. So what I can do? Yes, I can just press the button of reciprocal here 1 by x, and you can press in your simple calculator divide is equal to button to get the right answer, which is 2.90. So our answer here is 2.90. If the arithmetic mean and geometric mean for the two numbers are 6.50 and 6 respectively, then the two numbers are. So now if the arithmetic mean is equal to 6.5, then we can definitely say that the total of two observations, suppose the two observations are A and B, then the total of two observations will be 13, that is 6.5 into 2. And if the geometric mean of the observations are 6, then the multiplication of two observations will be 36. So we can just check our answer here, because this is a 1 mark question, so we cannot do much hard work for this. Let me check my answer. In this case 9 and 4, I can get the total 9 plus 4 is equal to 13, so I can fulfill this, and also 9 into 4 is equal to 36. Both the conditions are satisfied here, so my answer is 2, which is 9 and 4 here. Let us check other answers. 6 and 7. Yes, the total is 13 here, but the multiplication is not 36. In this case also the total is 13, 10 plus 3, but the multiplication is not 36. And in this case also the total is 13, but the multiplication is not 36. So we can very easily say, by fulfilling these two conditions, 2, that is 9 and 14 is our answer. If the arithmetic mean and harmonic mean for the two numbers are 5 and 3.2 respectively, then the geometric mean will be. We can use a very simple property that geometric mean square is equal to arithmetic mean into harmonic mean. So here in our case, geometric mean, which is not known to us, geometric mean square is equal to arithmetic mean, which is given 5 to us, and harmonic mean, which is given 3.2 to us. So it is 5 into 3.2. Now geometric mean square is equal to 16. Take square root on both the side, then geometric mean will be 4. So here in this case our answer is 4. What is the value of the first quartile for observations 15, 18, 10, 20, 23, 28, 12 and 16? Quartile divides the data into 4 equal parts. Let's see here. Suppose this is the line of observation, then the quartile 1 will be here, quartile 1, this is say quartile 2, and this is quartile 3. Roughly you can see here that this is the 25% of the data, 25% of the data, this is also 25% of the data, here it is again 25%, and here it is again 25%. So we can say quartiles, there are 3 quartiles, Q1, Q2 and Q3, and they divide that data into 4 equal parts. Here we are required to find out the first quartile. Now the formula to find out the quartile is Q1 is equal to n plus 1 divided by 4th observation. So here in our case Q1 is equal to, what are the total number of n's here? 1, 2, 3, 4, 5, 6, 7 and 8. So it is 8 plus 1 divided by 4th number of observation, which is 2.25th observation. Now how will we find out 2.25th observation here? Oh, first we have to arrange the data into ascending order. Let me arrange the data. The lowest observation here is 10, so we can start with 10, then the second one is 12, after 12 we can see here it is 15 and it is 16, though and so on, but we here only need 2.25th observation, so we can find out our answer by by arranging only first 4 observations. 2.25, we will just use a very simple interpolation here. We can say it is second observation plus 0.25. It is a 25th% of third observation minus second observation. So it does mean that third observation, second observation have a distance of 3, and I just want to take into account 25% of the distance 3. Let us put all the numbers here. Second observation means 12 plus 0.25 of the distance of third and second observation, which is 15 minus 12, so it is 3. 3 into 0.25 is going to be 0.75, so 0.12 into 0.75, so our answer here is 12.75. So we can very easily say that the answer is 12.75. The third decile for the numbers 15, 10, 20, 25, 18, 11, 9 and 12 is. To find out the deciles, first I need to arrange the data into ascending order. Let me start with the smallest observation here, which is 9. So it is 9, then the next one can be seen 10, then the next is 11 and the next is 12 and so on. Since I am asked here to find out the third decile only, what I think is I will get my answer within this 4 observation, because first decile is nothing but a 30% part of the total observation set. Now the formula to find out deciles is equal to n plus 1 divided by 10 into the number of deciles, So we can apply this formula here like this. Let us put D3 here for third decile, and the formula will be the n is 3 plus 3 6 plus 2 is 8, 8 plus 1 divided by 10 into the number of decile is third here, so it is 3. So 8 plus 1 is 9 divided by 10 is 0.9, and 0.9 into 3 is 2.70 observation. Now we will use the linear interpolation technique which we have used just in the previous question. So it is second observation plus 0.70 of the distance of third observation and second observation. So we just want to have the 70% of the data of the difference of third and second observation. Let us fill the numbers here. Second observation is 10 plus 0.70. The third observation here is 11. So 11 minus 10. So it is 0.7 only, because 0.7 into 1 is 0.7. So 10 plus 0.7 is equal to 10.7. So here in this case our answer is second, 10.7. If there are two groups containing 30 and 20 observations and having 50 and 60 as arithmetic means, then the combined arithmetic mean is. Now the formula of combined arithmetic mean is x bar combined is equal to n1 into x bar 1 plus n2 into x bar 2 divided by n1 plus n2. Let us fill the numbers into the formula. n1 is given 30 here, so 30 into x bar 1 is given 50 here, so 30 into 50 plus n2 is given 20 here, so 20 into x bar 2 is given 60 here, so 60, and we will divide this by total number of observation, which is 30 plus 20, which will be 50, is equal to 1500 plus 1200 and divide it by 50. So it is 1500 plus 1200 means 2700 and divide it by 50. So our answer is going to be 54 here. So we can say that the answer is 3, which is 54. Now let us find out a surprising shortcut to find out the combined mean. So this is going to be a very interesting shortcut, so we can solve the question in a very fast manner. My mean number 1 is 50 and the second mean is 60. The distance between the mean is 10. Now what we have to do is we can divide this distance 10 into the ratio of number of n, which are given 30 and 20. So I can say the ratio is 3:2. If I divide it, then the number here it will become 6 and the number here is 4. Now we just have to cross relate both the numbers. 50 will be related to 4 and 60 will be related to 6. You can find out by doing the by applying the two-way here. You add 50 plus 4 and you will get 54, which is our answer, or you deduct 6 from 60 and you will get 54, which is our answer. So the first way is 50 plus 4 and the second way is 60 minus 6. So this is a very simple shortcut.